Good evening, everybody, and welcome to the 5th episode of our first season of Check-In. I'm Francis O'Rourke from the Robo Sports Network, and we're all very excited to be here to show an inside look at some of teams from, in first all across the country. So before we get started, I wanted to thank this show's sponsor, Andy Mark. You know them, you love them. They provide a lot of great parts for first robots. Check them out at andymark.com. They're a sponsor of the show. They help make us let us do this awesome stuff that we do. I'd like to also thank RSN's other sponsor, Symbotic. Symbotic is a warehouse automation company. They're from Wilmington, Massachusetts. Learn more about them at symbotic.com. Really cool technology. Check it out. So, deadlines are now in sight as we finish the 4th week of the build season. I'm excited to hear from all of our teams. We're going to bring each one up one by one to discuss their week, then do a brief intermission between each group. So if you see the stream, we're not going to go off, but you're going to see a brief intermission. Just wait a few minutes. We'll be right back. Also, we're going to do Q&A with each of the teams. So if you have questions for them, send it to us via Twitch chat. Just type !Q followed by your question, and our chat bot will pick it up. And if we like it, we'll ask these guys live on air. All right, let's introduce our first team here. We've got Team 319. They're Big Bad Bob from Alton, New Hampshire. Let's take a look at their video they prepared from this past week.
So, Devaney, what are you up to?
Sewing our Velcro to our rope.
Wow. Are you having fun with that?
Absolutely.
Okay, great video, guys. That was a lot of fun. So viewers who've seen this show a few times may notice that we're got a little bit of a different layout this year, or this episode. So why don't I introduce the 3 guests we have here from Team 319. Jamie, why don't you start us off?
Hi, I'm Jamie Westlake. I'm a co-captain, and I machine things.
Cool. And Hannah, why don't you go?
Hi, I'm Hannah Mellon. I'm learning programming and software.
Excellent. And last but not least, Nico.
I'm Nicholas Nethery, and I'm part of the build team, and I help CAD.
Very cool. Well, welcome to the show, guys. So first off, Jamie, why don't you tell us a little bit about why you're doing this from your house? Isn't it build season? Shouldn't you guys be building robots?
Yeah, we should be, but we're up north in New Hampshire, and Inconveniently, we had a snow day today at the school, so we're not allowed to be at the school. So what we had to do was just stay at home and call from our computers instead of at the school.
Oh, very cool. So what kind of stuff did you guys do today? What can you do remotely for your team? Because I know this is like a period of time when it's very much like got to build the robot, got to put it together. So what were you guys up to during this?
During the snow day, a lot of people were just like outside doing stuff. We weren't really working on robots. A few people may have been working on chairmans. I don't know. I haven't really been paying attention to that. Today is more of like a day off, get some sleep, take a rest from robots day.
Okay, yep. Well, that's not a bad thing always. It's good to have a little bit of a break.
Yeah.
How about you two guys? Do you guys do any robot stuff today? Or do you just do homework and other stuff?
Homework and chores.
Oh, there you go.
Yeah, homework.
Womp womp. Well, sorry guys. Can't have robots every day, I guess. Oh well. Well, that's good to hear. I'm glad you guys are taking it well in stride. Jamie, how often do you guys have snow days? Is this a rare occurrence, or is this an every single season occurrence, or is it a multi-time a season occurrence?
Well, of course it's weather depending, but of course it's going to be winter. So, out of the 4 years I've been in high school, we usually have 3 or 4 snow days during the winter, which also encompasses build season. So we also lose 4 days of work.
Okay. Well, so how do you guys handle that? Do you just kind of buckle down, or is there basically flexibility in your schedule to sort of allow for these?
I think what we're going to do is just have a couple later nights, and work harder, get more done in the day, basically.
Yeah. Do your job, stuff like that.
Yeah.
Cool. All right, that sounds great. Well, glad to hear you guys are taking it all in stride. Also, just to let everybody know, at the end of the episode, at the end of the segment, we're gonna show a quick video about what everybody else on 319 did during their snow day. So it should be a fun little bit. Next up, let's talk a little bit about the 2 robots you guys are building. Why don't we talk a little bit about that?
So right now we have the 2 chassis, and they're assembled and welded together, and thanks to Jamie who milled those. And then we have the 2 robots split, or not split. We have them separated, one with the build team and one with the electrical team and programming team. And one is being assembled with the manipulator, shooter, elevator, and gear collector, while the other is being outfitted with motors and all the electronics and any radio and anything needed in that area. And the programming team works with that, and then build team, like I said, is assembling it. And that's just and then once that's done, we basically switch the 2 robots between the 2 teams, and then finish the assembly, vice versa.
Oh, okay. So you're basically paralleling out the 2 robots being built at the same time.
Yes, getting as much done as we can at the same time, so we're not having to wait for the other team to finish.
Very cool. Awesome.
Yeah, we find it's a lot easier that way to, have one robot for build team and programming team.
Yep.
That way we can each work, and then once we've gotten to a point, like a stopping point, we can just switch and do everything we did to the other robot.
Okay, cool.
If they're identical, we have the ability to do that.
Nice. So I know a lot of teams will build one whole robot, and then they'll use that as a practice robot, do a bunch of testing, and then rebuild a whole new robot from scratch. You guys, however, you're building basically 2 robots kind of asynchronously. Do you guys find that? How do you guys go about updating the robot when changes are made? Do you have to make a little tweak on one robot, then go and steal the robot from the other group and then tweak their robot too, or how do you do that?
Pretty much. We'll so when competition starts when we're practicing even with one robot, because we have one for competition, one for practicing. Mm-hmm. We'll practicing with one robot, we'll realize that this can be fixed, or we'll update something on that robot, and then we'll give the make that one robot, if it was during competition, make that the competition robot, and apply the changes to the other one that has not been changed yet.
I see. Okay, cool. So before we get to the electrical and software part of these robots, let's talk a little bit about mechanically how they're going together. So I heard a story that you guys machined your robot, or a lot of your robot, all at once,
Yeah,
perhaps. You want to talk about that, James?
What happened was we didn't know that we had to make a pocket in a very small piece that was going onto the drivetrain. And when we welded it on, we looked at the CAD again and we were like, oh, there has to be a pocket here.
This is after it was welded?
Yes.
Okay.
So we took the whole drivetrain and we flipped it upside down and we clamped it on the mill and made the pockets that way, which was really annoying, but it worked.
That's pretty crazy. Wow. So notwithstanding, how is everything else mechanically coming together? Do you have systems that are you full bore assembling stuff? Or are you still trying to make parts to give to the people to assemble, or what's the status in that realm?
Well, as you saw in the video, we have the frame basically, and right now we're just building the arm that we have in CAD right now. So I'm just machining pieces.
The arm? What does the arm
Yeah,
do?
we have an arm that will pop out at once the match starts because, bumper rules.
Oh, yeah, the collector.
Yes, our collector.
Oh,
So
okay.
we'll just collect balls that way.
Very neat. Cool. So what else is going on? You're right now building the collector. Are you able to assemble parts on your one build team frame right now, or is it kind of in a dead space right now?
Yeah, we're definitely assembling stuff. We're laying out a lot of electronics and things right now, actually,
Oh,
as
cool.
you saw in the video.
Yeah. Well, that's a really great way to sort of segue into this stuff. So, Hannah, I know that you're working on the programming and wiring team. Why don't you talk a little bit about that stuff?
So should I start with electrical or programming?
Let's start with electrical because it's a good transition from the physical to the ethereal, we'll say.
Okay, so this year we were doing a lot to try and clean it up. Last year, even though we had a really compact design robot, it was hard to access things like getting to the Robo Rio or getting to the router. So what we're doing this year is we're going to put them on the side of the arm and have the other things that aren't as necessary, like talons and motors on the inside hidden underneath.
Oh, wow. So does that mean part of your electronics are actually going to actuate and move during gameplay?
No, they're not on a moving part, but it's
Okay.
like the shoulder for the arm. I'm not sure what else to call it.
Yep. Okay, that makes sense. All right, cool. So is that mostly just because of ease of access compared to last year, or is it because your robot frame is smaller than the previous years, or a little bit of both?
A little bit of both, but mostly ease of access.
Okay.
We really needed it to be easier this year.
That's a good thing. So have you run into any snags so far, or anything that maybe you'll be doing differently on the second robot you build?
So far, nothing too complicated. We've decided that we're going to make these 3D printed SRX ribbon cable cases. They're orange and they say 319, and they prevent the ribbon cables from snapping apart. We're using entirely Anderson power pole connectors, and we're using the ferrule crimps connectors to make sure we don't have any fraying wires.
Oh, okay, cool. That's always handy. Nice. So, do you guys have access to a 3D printer, or is this somebody else at home or something? Or
Yeah, we have access to a 3D printer. The school actually bought two at the beginning of this year for a CAD class that they have. So
Nice.
a lot of kids in that class will just make something, and then they'll give it to the teacher, and the teacher will print it out.
That's awesome. Very cool. All right, so let's talk a little bit more about the software side of things. We saw in the video there, it looked like the robot was delivering a peg. Was that a driver, or was that autonomous?
That
I'm
was
pretty
the driver.
Ah,
Yeah.
All right, well, it's still pretty cool, though.
Our goal is to have autonomous down pretty soon, but a lot of that depends on getting the physical robot completed. So far,
Right.
we've just been using the robot from last year with plywood.
Just for
Okay.
practice purposes.
Yeah, makes sense. So tell us about the rest of the software that's going on with your robot so far.
We got a lot of the basic things already written. We have a rough design of an auto routine that we want to do. It's not completed yet, but it's pretty close.
Okay.
We checked our is finished statements, and we want to make sure that we have all of our methods and commands done. No command groups yet, but a pretty good frame to start working from.
Okay, cool. Do you guys do like a formal code review, or is this where you guys all get together and just check the code to make sure all the semicolons are in the right spot or what have you, or is that kind of what you guys been doing this week?
That's kind of every day. You just wait until you see the angry red exclamation points that tell you you've done something wrong.
Well, that's certainly one way to do it. Very cool. So, do you think that you guys are basically like, I don't want to say feature complete in the code, but are you completely out of stuff to do before you get the physical robot, or do you think there's still some open questions to tackle before you get the physical robot done?
There's always something left to do.
Ain't that the truth?
Not sure what it would be yet, but something.
Okay, cool. So I guess the next thing I'll sort of ask is, I got to ask, do you think you guys are ahead? Do you think you guys are behind? Do you think you guys are way behind? Or do you think you guys are like on time?
Because of the snow day, we're probably behind right now.
You're probably what?
Because of the snow day, we're probably behind right now.
Okay. Oh, your microphone just did a little thing, by the way. So we can't hear what you're saying. But what do you guys think, Nico and Hannah?
In terms of last year, we were looking at our schedule from last year. We're we're 3 days. But like last year, by last Saturday, we had a robot that was able to drive and actually was pulling a teammate around. But at this point, it's just because this snow day, and we actually had another snow day a couple days ago, or I think it was a week ago, that slowed us down. It's basically the weather that's been hindering us.
Yeah.
Yep.
And we've been taking Wednesdays off.
Well, there you go. So you've got some extra built-in time to add on to the schedule if you have to.
Yeah.
That's
Yeah.
good, yes.
The Wednesday was just to help with grades and homework so we don't fall behind.
I guess so. I guess grades are important. Whatever. Okay. Well, hey guys, thank you so much for joining me. Stay warm. Don't go out in the snow and the freezing rain. It's pretty nasty out there. And thank you guys for coming on and doing check-in even from your own homes. It's really great to see you guys.
Thank you.
Thank you.
Cool.
Bye.
So we're going to go to our next team. Our next team up is team 3940. They're Cybertooth. They're from Kokomo, Indiana. But before we get to them, we're going to show what these guys put together for a video during their snow day, and then we're going to take a very quick break and bring our next team on. So Big Bad Bob, thank you one more time. We hope to see you guys next week. Bye for now.
Ready?
All right, welcome back, everybody. We're here with our next team for check-in. It's Team 3940, Cybertooth from Kokomo, Indiana. Guys, why don't you introduce yourselves?
Hey, I'm Gus. I'm team president.
Hi, I'm Maggie.
All right, good to see you both. Glad you're here. So let's talk a little bit about what you guys are doing. So you guys don't have a snow day, unlike Team 319, thankfully. No snow in Indiana, probably a really good thing. So let's talk a little bit about your team status. Let's talk about where you are overall in the build season and how things are going.
We're doing pretty well. We're pretty on schedule. We were a bit behind last week, but then we had a really great Saturday, and we got straight up to where we needed to be. We
Nice.
split off all our students into different subgroups and said these things need to get done today, and they did. And so now we're on track where we need to be.
Very cool. That's awesome to hear. So let's I want to kind of dive into into these things. So we saw a lot of different parts of your robot. We didn't see some parts of your robot. So let's talk about the ones that we saw. Looks like your frame is looking solid.
Mhm.
It's purple. Do you guys powder coat that, or do you guys paint it, or how do you do that?
We have a really great powder coat sponsor. So we powder coat our whole drivetrain and pretty much all the sheet metal on our robot.
Oh wow, cool. Is that local or?
Yes.
Very cool. That's awesome. That's good to hear. So the frame's going. Let's talk a little bit about your climber. We saw in the video that you had a little portion of the presentation there where you saw your climber break, or you said your climber broke, and then we saw it actually climbing. Can you tell us like what that story is?
I think the breaking point was just we didn't anticipate the bending of the shafts when we were building it, so we had to go with upgrade to a steel shaft for the climber, and so that was not a huge issue there. We actually decided this past week that we need to integrate our climber into our gear pickup off the floor, and so that's going pretty well as well.
Oh wow!
Mhm.
So what does that entail exactly? Are you starting over from scratch, or are you just kind of taking what you have and slapping two things together and calling it one, or how does that whole process work?
For our main gear design, this wasn't the one that we chose to incorporate with the rope. It was the one that best fit, and so we actually didn't have to change much. I think we changed grommets to another type of wheel, but besides that, we didn't really do that much change.
Awesome.
Yeah, there had to be a bit of compromise for what motor speed and what torque we needed between the two. And so we had to upgrade to larger wheels for the intake and a smaller shaft for the climber, so that with the lower speed we could still get as much pulling speed as we needed.
Okay. So can you tell me kind of how it's going to work? Because normally the gear collectors should be low to the ground. What's your plan as far as actually grabbing onto the rope and climbing the airship?
So we're planning on having the kind of latch mechanism that we have on our climber on the shaft between the wheels for the gear pickup. And so, yeah, our climber is going to be pretty low to the ground with that gear intake.
Okay, Cool. So you're basically gonna start like this and sort of grab the rope and do one of these and go all the way up to the top.
Mm-hmm.
Nice. Cool. All right. So let's talk a little bit more about your intake. That was one of the things that it looked like was being like blurred there.
Yeah.
So we want to hear the story. We've seen the blurred video already. It was on Twitter. We want the real deal. Tell us what's up. Why is it blurred? What's so cool about it that makes you guys want to hide it?
It's our baby.
So we've really put a bunch of time in this intake, and it turned out even better than we thought it would. We realized that it's one of the most integral parts of our robot because we want to be fast and we want to be able to pick up balls as fast as we're driving. And so when we found that it was as fast as it was, which is about 30 balls per second intaked into our hopper, we realized that we want to keep it under wraps how it actually works for a little bit.
Ooh, I see. Nifty. All right. So, but let's get a little bit of details about it if we can. How does it work? Is it belt driven? Are there wheels anywhere that like pick the balls up? And does it go through the bumper or does it go over the bumper?
We are doing 2-inch compliant wheels, and it goes above the bumper.
Oh, okay. So it pulls it up over the bumper into the robot.
Mm-hmm.
Nice. So in the video we saw there, it looked like the people were shaking the collector to sort of make it move, which kind of makes it weird now that you say it's your baby. But so how is that just like a thing because it's a prototype, or because it's not on your real robot yet, or how are you going to deal with sort of getting that many balls into the robot, or maybe even you're not going to pick up that many that quickly?
Well, we had to with that prototype. We ended up accidentally driving one of the shafts the wrong way, and so that was obviously a problem. So
Yes.
The shaking was just we were trying to figure out where we could get a drill running to get it to run the right way and stuff.
Oh, okay. All right. That's a real good answer. Very good. All right. So let's talk a little bit about your shooter redesign. That was also a little bit blurred out, but I saw two things I want to point out. One, we saw your turret mechanism. Looked like you had your lazy Susan there, which looked really good. And then we also saw a lot of balls go in a very straight line very quickly. So please tell me about that, because that looks wicked cool.
Well, we are redesigning everything, and so we needed to make our shooter wheel smaller. And so Saturday we practiced and tested to see if we could, and we figured out that we can without like no changes to our accuracy that we already have with the bigger design.
Yeah, so last week we were concerned about the amount of wrap that the ball was getting, because we didn't think we would be able to make the almost vertical shots with such a small hood. But we did some testing on Saturday, and we found that we can get rid of the underhang of the ball that we had planned on last week. So we really made our shooter a lot smaller, and it's really helping us out a lot because it's conserving a lot more hopper space for all the ball storage we'll need.
Nice. That's great. So because of that, I know that your plan is to shoot from near the boiler and shoot it pretty close. But we saw in that video, it looked like it was shooting at a lot longer distance. Was that just an accuracy test, sort of to see the variance over a long distance, or has part of the plan been modified now that you see how cool this guy works?
That was pretty much our software group testing out PID control with all the balls kind of shooting in the straight line. We plan on shooting a little bit closer to the boiler than that. But yeah, that was more for accuracy's sake.
Okay, cool. And maybe I missed this. Why did you guys redesign the shooter? Was it just because of packaging issues and wrap issues, or was there other concerns driving it?
Yeah, we found both the wrap issue where we needed more room and less wrap if we wanted to do what we were going to do. And then also we were a bit concerned because with the extra wrap that we had, the shooter would go outside of the robot frame perimeter, which was fine with the spacing that we have. It's just we are concerned about robots playing defense and potentially breaking our shooter, which is the most important part of our robot.
That would not be good.
Yeah.
Very good. Cool. So why don't we talk a little bit about your CAD team here? So we saw in the video it looked like your drive base and your gear collector together. Tell me more about that.
Well, that is definitely not our final design. That's like just one of the many CADs that we've done here. but we have some students on the team and a couple of like fantastic mentors that have been really helping the students and have also been taking their own time out to help us CAD. And today, while we were talking before we had practice, I think they said that over 130 hours had been put in to our final CAD design.
There you go. Very cool. That's a lot of man hours. It's great to see when teams track all that stuff. It's a lot of fun to see all the hard work that goes into a robot, and great to quantify it sort of at the end. So well done, guys. Now we didn't see. I'm assuming that there are parts missing from that because part of it is the shooter, which is still in flux, and part of it is the collector, which is still under a pixelated shroud of some kind.
Yes.
I assume something Andy Mark's going to sell in the future. We'll see though. But what I want to know is, how do you guys implement changes back into the CAD? Do you guys, when you're changing the shooter, did you just slap a new wheel on there and go for it? Or did you go back into the model, check everything, put a new wheel in, make sure everything worked, and then implement it on the robot? How does that process work for you guys?
Well, our design teams, like our different subgroups, they will come up with their prototype and they'll have like the image of it, and then they'll take it to the people who can CAD in our team, and then those CADers will incorporate that into the design.
Okay, cool. All right, so the last topic we wanted to touch on was Shamrock Shakes. I honestly have no idea what it is, but
What?
I don't know.
Shamrock Shakes. They're a certain minty shake that's at McDonald's for a limited time. They really make our team shamrock.
Shamrockin'. Put that up.
It's kind of a tradition on our team for us to get Shamrock Shakes as season goes on.
Okay.
And it's stress relief of build.
It really makes our team in mint condition.
Oh, well, thank you to the mentors and the students of Cybertooth for dad joking me on my show. Really appreciate it. It's always a lot of fun. So the last thing I'm going to ask as we sort of end on a more serious note is where do you guys think you are? Do you think you guys are? You mentioned at the beginning that you've made up a lot of ground, but you did a lot of redesigning too. Do you guys think you're back on schedule, or do you guys think you're still a little bit behind, or do you think you're actually maybe even ahead?
I think it's hard to be on schedule on an FRC team during build season.
I agree with you, yeah.
But we're in a good spot. We're not too worried. We are going to a week 1 event, so it's going to be a pretty quick turnaround after build season's over. And we'll have that extra 6 hours prior to the district event, but we're not too worried about getting the robot done before then.
Okay, sounds good to me. Well, folks, thank you, guys. Thank you so much for joining us here tonight. Thank you so much for taking your time out and doing the show with us. Great video as always, and great impression. Thank you so much for playing my game. But so before we're going to bring over our next team in just a second. It's going to be Team 2337. They are the Engine Nerds. They're from Grand Blanc, Michigan. But for right now, thank you to Cybertooth for joining us this evening, and we'll be right back with our next team. Thanks, guys.
Thanks for having us.
horseshoes.
This is our
Your shoes.
All right, welcome back, everybody. We've got our next team up here. It's Team 2337. They're the Engine Nerds from Grand Blanc, Michigan. Guys, welcome back to Check-In. Good
Thanks
to
for
have
having
you.
us.
Can you guys introduce yourselves?
My name's Clinton Bollinger. I'm one of the co-head mentors of Team 2337.
I'm Alexis. I'm co-team captain and operator interface student section leader.
I'm Gus. I'm head of communications and senior programmer on the team.
Cool. Well, guys, welcome back. Glad you're here. Glad you're not snowed in.
Yeah.
So let's get started. Let's talk about all this cool stuff. First off, are you guys excited that former Michigan State quarterback Tom Brady has won the Super Bowl yet again?
I think we were building robots during that time. So
Okay. All right. Fine. All right. So moving on to the real important stuff. Let's talk about your practice and competition robots. We saw some footage in there, a good amount of prototype footage from your gear placer, but we also look at some pretty good-looking black sheet metal, which I assume is from your competition robot. Why don't you tell us what the status is so far?
So yeah, the black finished robot you saw is going to be our competition bot. It's powder coated, all nice. So right now we have the chassis basically done. We got some of the electrical done on them. The other robot that you saw was our practice bot, which we're going to be using for coding purposes and such. So for the chassis wise, it's done. We still haven't finished putting on the shooter for either of them, but we have put on the intake for one of them. So
you want to talk about the electrical that you did this week? So you helped with that.
Absolutely. So we have our whole practice bot. All the wiring is completed on it. We got some of our pneumatics on there, and we're able to move with a fully functional intake, able to drive around in intake balls. So that's
Nice.
a pretty big step for us. So now that we have this, we can work out any quirks that we find and keep moving on with our competition bot.
Very cool. So
And,
we saw. Oh, go ahead, Clinton.
I was going to say our method is usually we build everything on practice bot first. Once we know it's good, we then move on to making that same part for competition bot. So we kind of put all of our errors and mistakes into practice bot.
I see. Okay. So that's interesting because we actually had Team 319 earlier. They build two robots as well, but they tend to build them in parallel. What makes you guys want to put all your effort into the practice robot, then after that's done, all your effort into the competition robot?
well, I mean, there's always mistakes that arise from just making different things like shooters and intake and.
So sometimes we call those lightning holes. When a hole is drilled in a wrong location,
Yep.
that goes on to practice bot, and the correct one goes on to competition. Also, we spend a lot more time on the electrical wiring to make sure it's very clean, and lots of zip ties holding all the wires in place. And then we also only powder coat the competition bot.
Okay. That makes a lot of sense. Cool. So we heard is picking up balls, scoring gears, in your competition robots, assembling to get toward that point once you're ready. How is hanging going?
So we have mechanisms already like headed out. And,
They're actually machining right now.
Yeah.
Probably if you were to turn 180 degrees from where you are right now, you would see machining behind you of the climber mechanism. So the hope is by before the weekend is to actually have the climbing mechanism strapped onto the practice bot and actually climbing.
Nice. That'll be great. So then the last bit of your robot, which we haven't heard of, we heard a little bit about it from you guys, is the shooter. So I think that's probably where a lot of teams are spending a lot of their resources this year because it's probably the most time-consuming challenge. Where are you guys along with that? How is things going? When do you think you guys going to get it ready to put onto a robot and play with?
So I'll touch on this point. So we spent the last 3 to 3.5 weeks working on prototypes for shooter and the fuel tank for our robot, where all the fuel goes. We decided this weekend to take a pause on that, figure out finish up for production, the gear mechanism, the climber, intake, all that's gonna kind of go around all of our shooter and hopper mechanism.
Okay.
So we kind of like paused on it. We spent a lot of time developing it, and we have it all in CAD, and it's actually ready to machine. But we don't want to machine it until we kind of see if any of the hanging mechanism or gear mechanisms are going to interfere, and we got to make a design or priority decision based on those mechanisms.
Okay, that makes a lot of sense. That's a good way to do it. Good to make sure that the most important part of your robot gets the most attention when it's needed, so it's not interfering with everything else. Very good.
And like that, I mean, our feeling is, even though our number one priority for this year for us is shooting, the climber and gear mechanism cannot be ignored.
Yes.
Teams that do not have gear mechanisms and climbers, there's a chance that they might not actually make the eliminations. So we spent a lot of time on the shooter, a lot of time on the hopper, and we want to make sure that we're not going to fall into that where, hey, we don't have it because it doesn't fit because our shooter's there, and now we got to give up gears or give up climbing. We don't really want it.
No, I agree with that. So speaking about the shooter, I want to kind of touch on the control for the shooter a little bit. Last week, you guys mentioned that you guys were probably eschewing a PID loop instead of going with a bang-bang controller. I know that you guys said you have sort of pivoted away, but have you guys done any controls work on that or other stuff?
So again, we've been moving more towards our other mechanisms.
Yeah.
So we kind of put that on hold right now.
Okay.
I would assume that by the end of this week, we'd be finishing that up, finding out which one works the best.
We're still testing both of them.
Yeah.
Oh, yeah.
I mean, we're not counting either one out. Whatever one gives us the best recovery time, that's the one we're going to go with. If it's bang bang, if it's PID, if it's some other engine nerds loop or something like that, we'll go with that.
Cool. All right. Sounds good to me. All right. So let's talk a little bit about your partner showcase. Can you tell me a little bit about what that is exactly and what it means for your team?
So every night on Bag Night, we started this in 2015. We invite all of our partners out, which they're basically our sponsors, but we believe in like a mutually beneficial relationship.
Mm-hmm.
So we invite them all out, and we invite like our school board members, and we give like a whole team design review. So we talk about what we've done for the whole season, and then we network with them and show them in our robot for the first time. So they're able to ask questions and kind of experience what we do as a team. That way we're able to keep a close relationship with them. And what's really cool too is this year our superintendent's actually coming. So we'll be able to have our school board officials and like our partners.
That's awesome.
And we look at it as that they donate money and time and resources to us. The least thing we could do is pause on building our robot, even though it's the hardest time of the season of trying to get everything finished before we put it in the bag. We pause, let them kind of see and experience it. And then we've always typically had the owner of the facility we work out of actually signs off our robot during bag. So he's always the one to actually zip tie it and lock it in, kind of as a tradition.
Oh, that's very cool. And so this is planned for Bag Day in a couple of weeks?
Yeah, it is actually on Bag Day. So we will have to talk with check-in about how we're going to work it that night. So.
Sounds good to me. So I guess the question I have is superintendent of your school, that's actually kind of a really like big deal. There's a lot of kids in your school district, right? Like how many, like 10,000 more?
We have 3,000 people at our high school alone, so it's a very big school district.
Oh my goodness. Yeah. Okay. So
I think we're actually one of the biggest single campus school districts in the state of Michigan.
Wow. That's awesome. Well, congratulations to you guys. I hope your event goes well. I hope that the planning is going well. I guess the question is, it seems like you guys are real confident you're going to have everything ready for that day, right? You're going to have a great robot to show off to your sponsors and partners?
We must do a really good job up here of presenting that to you, yes.
Good. Excellent. Cool. All right, so let's talk a little bit about your plans before Bag Day, which is coming up in a week from Saturday. It's the Week 0 events. So a lot of them happen across the United States. The official one happens in New Hampshire, but a lot of local ones happen. And you guys are going to one in Michigan, is that correct?
So actually ours is actually a week 1.5. It's the weekend between Bag Day and week 1 actual events.
Oh, okay.
So we're actually going to be taking our practice spot there. Kettering University has a community center where they actually have a full field. They're inviting, I think it's a total of 24 teams out with 2 sessions. So each one has 12 teams. If you have a practice spot, or if you are actually competing in a week 1 event and want to use your unbag time, because we are in the district model, I think the teams that decide to unbag and use that field, they actually have to give up 2 hours of their 6. So they are only going to get 4 hours. But this is also used to train volunteers, field techs, field reset people, FTAs, all that in Michigan, so that they can actually see how the field reacts and how accidentally triggering the hopper is going to affect field reset and slow the whole process down. So we're fortunate enough to have this in our backyard and be able to attend this. Like I said, we plan to actually take our practice spot there and hopefully get a better idea how this game's going to play before we go to our event, which is in week 2.
Nice. So this will be on an actual real field, like an official FRC field?
Ish. It's a Frankenstein. So my guess is we haven't got it confirmed from them. So they have the Andy Mark field at the center. So they already have that. So that is the real field. I do not know if they're going to have the air station and the gear mechanisms. I assume that they're going to have something extremely similar to that. Like I said, they try to do that so that the field crew that sets up the field can kind of have a test run. Okay, so this isn't the FIM field necessarily, but it's a bunch of stuff that is close to it. Ish. Okay, ish. Last year, to give the examples, last year they did something very similar to this. They actually brought the real defenses from the First of Michigan fields, but they kind of had makeshift towers and stuff like that. So, like I said, it's kind of a Frankenstein where things that have to be the real thing, they bring it. Things that can be wood, they use the wood one. Nice. So, what are some things that you guys learned during these week 0 or week 1.5 events or 0.5 events? What are some of the things you're looking to test and practice or break on your robot? Go ahead.
Well, I mean, Auton would be a great thing to test.
Oh, yeah.
It's hard to get a feel for that.
Yep.
But also you got just how to run as a drive team too, just to get a general sense of how it's going to be, especially the view for this year with the 2 airships. It's gonna be hard to see. Yep. So yeah, it'll be hard. It'd be good to test that out. Sightlines, I think, would be one of the biggest ones this season. I think of going to that week 0. We even go to week 1 events in Michigan. Even though we're not competing, we go there just to scout and watch. See what the meta of the game is during week 1 to see if when we go to week 2 how that's going to play out. Right. Exactly. Yeah. And I mean, I was a coach for a few years as well, and you don't know how important it is sometimes just to practice just putting the robot on and off the field and who's got the cart and who's got the OI and make sure everybody's in the right spot. We get extra person this year, so we're good. Yeah. There you go. Right? Perfect. We can have a 4-man lift on the robot, no problem. More person, no man, but yes. So the last thing I want to talk to you guys about is the field elements. So you guys are, we see that you're in a different spot. You've got your new location. Yes, new location. You've landed the airship in your studio, it seems. Ready to take flight or something like that. I don't know. Yeah. So we kind of show you kind of what we have going on behind us. Yeah, we saw earlier that you guys were doing some gear flips, and it looks like your gear lifts are fairly accurate to the real things. Yeah, so actually, we actually worked on this last few weeks. This is the design based on the field drawings. So we actually have, the rope, and actually can lift the gear up just like the real thing. And just like the real thing, it could fall off if pilots aren't careful. Some interesting points that we actually have is that when the pilots are up here, we do actually have a piece of Lexan. You can kind of hard to see it here, but we do have the hole. So it is possible for the pilot to drop the cord outside, and they might not be able to do that anymore. Same thing goes with, there is nothing retaining the rope from actually going completely outside of the gear mechanism. That can happen. Yep. And the last thing that we kind of noticed is that when you tip this down, there's actually nothing retaining this from actually coming out of there either. So this whole mechanism
could possibly, if it happens at an event, I'd like to see a picture of it where the whole mechanism could end up on the floor, and you're really out of luck, right?
So that's why they got 3 lifts, I assume, right? So you can, ditch one of them if you have to.
Yeah. We built all 3 so that we can have our pilot practice lifting the different locations and for the driver to kind of see the different angles for doing that. But
you guys started practicing already, or?
We've just did a couple tests. We don't actually have our full drive team picked out yet, but you can kind of see over here on this one. If you actually have it on the end of the rope, you can actually you can pick it up and bring it back in. But if you do have it on the end of the rope, you want to put that on there. You're really good at doing that.
Yeah, we saw in the video. Great tricks, by the way, man. Well done.
So if you actually accelerate fairly fast, it does come off.
Oh wow. Okay, that's good to know.
The other thing is if it's all the way back on the back side, you can actually pull up fairly quickly. I'm kind of blocking the view, I think, but it does hold on. So
okay, that's good to hear. Very cool.
And then I don't know if we're gonna swing over to the side here, and Josh can probably talk. We have full-blown hopper with the trigger mechanism.
Oh wow.
So yeah, okay, we built the hopper out of the steel parts here instead of the wooden one they give you.
Yep.
And there are some things that we realized, like the trigger points on it. Obviously if you're pushing at the top, it's going to be easier to trigger than down at the bottom. But at the bottom's where the Lexan plate is, so there could be a team, with the bumpers restricting you, it may actually be hard to hit this top part where it requires less force.
Yep, that's true.
And then also,
yeah, go ahead.
So when you trigger it,
nice.
The hopper still sticks out past the wall, so that's another thing to note there.
Oh, so you can't slide across the wall flat.
Yeah.
You just have to be aware of it. The last thing is a lot of teams, what they're doing, I think, when they're doing prototypes, is if this is their robot, a lot of teams are going right up against it.
Yep.
Reset it. And we move it about, 3 inches, the space of a bumper, and kind of pull it back. And actually, if the robot was up a little higher, hold that back there. If we kind of trigger it.
Uh-oh.
If people aren't taking their bumpers into consideration, there's a chance that they could miss a lot of the hopper load. So I don't know if anyone has any questions about what we have here.
Yeah, well, everybody at home, make sure you check with your real robot. Never hurts to put a real set of bumpers on there, even if it's just as a spacer almost. It's always good to double check all that stuff. So that's great. That's great to hear from you guys. So I think that that's going to be just about it for us for the Engine Nerds for this week. Thank you guys for coming on once again, and thank you all for doing this and showing us your field. It's a lot of fun. Up next, it's Team 3847, Team Spectrum. They're from Houston. We're going to have them on in just a second, but one more time, thank you so much to the Engine Nerds for letting us into your shop. It was a lot of fun to see all the cool field parts you've built. So we'll see you guys next week, but bye-bye for now.
Thanks, guys. See ya.
Bye-bye. Thanks, guys.
getting this rubber on a metal pipe. 3, 2, 1.
Alright, so this is our shooter. It's called our 3 wide shooter. It shoots 3 balls at once. We're using 4 7.75s to power the drums, which shoot the balls into the goals. In addition, we're also using some back motors to power the pulley system, which brings the balls up from the bottom to the top. And that's about it.
Hey! Can you make me go far? I don't think so.
And we're back here with Spectrum on check-in here. Guys, welcome back to the show. Good to see you again. Great video as always. A lot of very fun stuff. Before we get into this stuff, why don't we have you guys introduce yourselves to everybody at home?
I'm Will. I'm a senior on the team, and I'm part of mechanical design and chairman's.
I'm Alan. I'm the head coach for the team.
I'm Mary, and I do some of the design too.
Very cool. All right. Well, welcome to the show. So our first topic, we're going to get to all that cool robot stuff you saw a little bit later, but we're going to talk about some other stuff that Spectrum also is part of. Tell me about the Chairman's Award. So for those of you who don't know, the Chairman's Award is the highest award you can earn in FIRST. It's primarily done with a presentation, an essay, and a video. And the essay is due, I think, 2 days from now, I think?
Thursday, I believe. Thursday,
yeah.
Yeah.
So how are you guys doing with it? How's everything going?
So I've been on part of the chairman's the chairman's process for 3 years now. And I have to say, this is I think the easiest year for us for it. not because of content, but just because every other year we have tried to cram it into the last month of being able to actually work on it. Whereas this year we actually got started back in November with having some of our team members write draft paragraphs for the executive summary. So normally it's our previous process for it has been, all right, here's last year's executive summary, last year's essay. How can we tweak these and add in the new stuff from this year and just update it? But this, after a 2-year chairman's dry spell, we were like, all right, we need to change something. So we decided to completely scrap everything we'd written, have people who'd never written essays for us for chairman's write them, so that we didn't have any of me or Alan's, the language that we like to use and our way of saying things. That we got other people's phrasings, other people's word choice, and then we just did a lot of the the top level editing, getting stuff down, making the word choice a little bit more succinct, and making everything flow a little bit. But a lot of the structure was from people who have never done chairman's work before, and we think it turned out pretty well. And it just allowed us to not have to cram everything in 10 days.
Just totally cool, totally okay with it.
Yeah, so we'd finished our executive summary right at the beginning of build season. We had sent it out for review. So we use a couple different people from around FIRST. There's a couple of great resources on Chief Delphi that people have volunteered. Amanda Morrison.
Yeah. And Cassie Beck. They both have threads on Chief. You can PM them, email them, and they're willing to help you out. We got a lot of good feedback on, word choice, whether or not something could be easily misinterpreted or, whether or not something seemed excessive. Usual kind of editing.
Getting other people from outside your team to read it, because everyone on your team knows what you do, and it may make sense to them. But when you have other people outside of it, we also get some people from outside of FIRST. We have some former parents who are still helping us every once in a while, so we send them our essay and get notes back from them. I actually send it to my mom, who's a librarian, so she helps give feedback. So anybody you can get feedback from is fantastic.
Yeah, and hey, we got everybody out there has got 2 days left. So if you haven't submitted your essay, might as well send it to anybody you can that you think can give some feedback on it. You still got time to change it. So
Absolutely. Yep. And then so as we wrap this up, we'll start going into getting our presentation ready. So we've already been doing practice presentations basically with last year's presentation. So we have other people who are going to be giving it this year, rehearsing, making sure we get all of the presentation cues and stuff down. And then we'll rewrite the actual presentation and get what they're going to be saying up here in the next 3 weeks.
Okay, nice. So something I kind of want to touch on is I've seen a lot of chairman's essays that have a theme or sort of have a way that they follow a story or have a grand sort of I don't want to say arc, but like almost like a theme basically to the whole essay. How is your guys' spectrum? How is your guys' essay structured like that?
So we're generally not much of a fan of like the themed or sort of like the story essays. We sort of take it from a slightly different approach. We like to use our essay to present information to the judges. We think that it's a good way for us to sort of give a solid baseline for our presentation, and our presentation is where we get more of like the character into it and a little bit more of the personal impact. The essay is a lot of these are the kinds of things we do. This is why we think that they are important. This is how these 10 things that we do fit together into this under this one theme. Sort of like we go from like how our team got started into how the team operates to some of the team's volunteer work to volunteer work specifically within robotics to how we interact with the robotics community, and then we sort of wrap it up with a conclusion.
Very cool. I like that too. I like it. I think that's a great way of presenting it as well, because it's basically giving the judges everything you do and saying this is what we do, this is why we're awesome, and then I'll give the personal side with the people who are quite frankly the best at doing that. So very cool. I like that.
Our presentation isn't like themed overly either. It's not really. It's about as far from a skit as you could get. Right. It is 3 students walking in and giving a presentation about what we do,
right,
and what we're doing and why we're part of FIRST and why it's important to us and why we're important to our community.
Okay, because I see with the name like Spectrum, you can do like like rainbow themes or what have you like that. I think that would be great.
Yeah, every once in a while there's a light pun, but we try to keep them sparse.
Yeah, it's all like suits, ties, dresses. Like we like to keep it formal and
nice.
It's worked out pretty well for us in the past. We think that the judges appreciate it when we have high school students who look like they're able to give a professional presentation and just seem mature and like they have all their ideas collected and they're not just like coming up to like act something out or like try to make a few jokes. Like that has its place, but this is really like you're trying to inform the judges and leave an impression of a team that upholds these the values of FIRST and Chairman's Award is trying to celebrate, and we just feel the best way to do that is to be professional and to say hey, we take this seriously, and it's something that we are really proud of.
Cool. All right, so speaking of all the things you guys do, tell us a little bit about the How I Work series. I know that this is a thing that you guys do with mentors around FIRST. Why don't you tell folks what it's about?
So How I Work is basically us reaching out to other mentors that are really amazing at what they do, and we email them a little interview and they fill out all the questions, and then we format it, put all the pictures, and then we post it onto our blog. It's really amazing because there's a lot of cool stories that no one really knows because there's not really a chance to tell every single person all these really cool stories. So I think they're really, really amazing in that way. And
yeah, I mean, I love reading them whenever they come up on Chief Duff Fight. It's a lot of fun.
And there's just really, really cool people I never knew about, and it's amazing. Also, this year we have trading cards, which is a whole new thing, and it's really exciting. We're planning to print them out and hand them out at competitions, and the people who are making them after are really excited about it too, so it's really awesome.
Nice. How large is the set? Is it like collect all 5? Or are we talking like 50 people?
So this year we're coming out with probably about 10 to 11.
Okay.
We have ready, and then we'll be rolling out the rest of them as we get new people signed up and things. We'll be getting everybody's card hopefully.
Cool.
We're just part of the goal of the program is because we have all these awesome mentors who work for great companies and they do all their work and they get to be mentors for their own students on their team, which is great. But we want to make sure that their stories are inspiring students around FIRST. This is one of the ways that we're able to do that.
Oh, cool. That sounds like a really cool idea. I like it. I'm look forward to trying to collect all 10 at the Houston Championships. That'll be fun. Go ahead.
And we'd also like to say just a little thing that we're always open to new people doing the How It Works series. We always love to have more people do it. So if you want to be part of it, you can email us at team@spectrum3847.org to be a part of it.
Cool. All right. Well, again, the email address is team@spectrum3847.org. And if you want to put yourself out there and get grilled by these guys, and they're really tough questions, I'm sure, they'll be happy to have you. It'll be great to hear. So let's talk about our next topic real quick. So back to robot stuff. You guys have a lot of varied machining capabilities that you guys use. We know you have a router. We know you do a lot of sheet metal stuff. We saw you guys, looked like you guys were actually doing some powder coating in-house maybe, or at a sponsor perhaps. But what I want to talk about is 3D printing. You guys seem to use a lot of it.
Yeah, this year especially. So we ended up starting to do some of it just as prototype stuff. We were printing pulleys and things and prototyping. Then we realized they work phenomenally right now. So haven't broke them yet. So right now the plan is for almost every timing belt pulley on the robot to be 3D printed.
Wow.
So we're able to print. We've been playing around with a few different new materials. For the last 2 years, we've been printing out of polycarbonate on our Airwolf printer. So we actually do 100% fill polycarbonate parts. So they're solid. So we don't want to do it on like a drivetrain or anything. But in most places, intakes, they're totally fine. We also, in a bit of a weird story, we had a alumnus from the school who we still unnamed anonymous alumnus at the moment, donated a 3D printer to us that we had no idea was coming. So we got a second printer about a couple days into build season this year.
Oh my God, that's a great gift to get.
It was pretty phenomenal.
Wow.
So we've gotten that one up doing. We started printing in PET G with that one, the same plastic that soda bottles are made out of. Which is working out pretty nicely as well.
So all your time belt pulleys are made of polycarb, not this new PET G plastic?
A little bit of both right now. We're trying to figure out which one's the best. Most of them are polycarbonate because that's what the printer we had before. But we have some that are coming out of PET G. And we're also printing all of our spacers. We have a lot of different, our power switch mount will be printed that way. We have a lot of different parts that get printed on the robot this year.
Wow. Great. So, and especially because a lot of your students are doing a lot of modeling, it makes a lot of sense to have a rapid way to turn that model into something that they can touch and play with and actualize. It's great. So the last bit we're going to talk about is actually the progress update for your whole robot. So last week we saw you had a completed CAD, and you were sending your parts off to basically your Santa Claus wish list for sheet metal Christmas. Where do you guys stand on that, and where do you guys stand on the rest of your robot? We saw some climbing stuff happening, which is great. So tell us what's up.
The current schedule we have from our sponsor is that the sheet metal should be ready for pickup sometime tomorrow around noon. So Alan will go out, pick it up, and we should have it for the start of our meeting tomorrow. Then the climber, which you saw in the video, that was our vision from sometime middle of last week. We were experimenting with ways to keep the strap from just sliding all the way down to the edge of the roller. So we had mounted, I think like 3-inch diameter pieces of wood with some plastic rolled over it to just create a little bit of a ditch that it can sit in, and that pulled it straight up. It did move to the corner, but that corner is closer to the center, so there wasn't as much tip. And then later in the week, we started experimenting with cones on the roller, or a V shape at the above the roller to help center the strap. So it looks like right now the V wedge is going to be the best thing that's going to work. The cone wasn't it wasn't sliding along the cone as well as we would have liked. One team member thinking about like wrapping a screw around a cone, but I don't think he ever did that. I don't know. We'll see what happens. And then we're also moving on to changing some of the materials on that.
And then, like you said, we were powder coating some things. So Mary, you want to talk about our powder coated parts?
We have an in-house powder coating. We actually powder coated some of our VPs. So.
Oh my goodness! Look at that! Wow. So they don't come as white. They're normally black, right?
Yeah.
Yes.
Yeah. So
what's the process to get them powder coated? Do you have to strip the existing finish off, or do you just go right over top of it?
Goes right on.
So you basically just have to clean off all the grease and oil, and then you just lay the powder on.
Yeah. Wow. So that's a new thing that we just got this summer. It's basically just a large toaster oven and the powder coat gun. It's pretty simple. So the nice thing about it that we really finally went for it. We had heard other teams doing it, and we weren't really sure. But we realized that it's faster than spray paint, and that makes it a big boon for us. So we can basically, you can take a part and have it ready to mount on the robot within an hour. Nice. And that's much faster than spray paint.
So I got to ask, just so the people at home know, when you say it's like a large toaster oven, it's not actually a toaster oven.
It says powder coating oven on the side of it, but I'm pretty sure you can also buy the same thing that says toaster oven on it.
Does it have a light or a dark setting on it? Because that might tip it off.
It has a function on and off button. We're not sure what it does, but it has to be on. But we don't we don't understand why there's that switch. We don't know what it is.
So really quick before we go, can you tell us where you guys got that stuff? Is this like high end stuff, or is this like Harbor Freight stuff?
This was from. Oh, good question about the name.
Eastwood.
Eastwood. There we go.
Eastwood,
Good job. Yeah, it's Eastwood Company. It's the same people. They do a lot of stuff to powder coat engines and things for people who are modifying their cars.
Cool. All right. Well, guys, thank you once again for joining us. We hope that you have a productive next few days. Hopefully, no snow days down in Houston. And that we hopefully, judging by the speed you guys work, we expect to have 2 robots done for our next check-in show. We'll see.
One at least.
That's all right. All right. So next up is team number 148. They're from Greenville, Texas. They're the Robo Wranglers. We're going to bring them on after a very quick break. But before we go, I want to say thank you to Spectrum one more time. And we can't wait to see you guys next week. So bye-bye for now, guys.
Thank you. Bye-bye.
Thank you.
up? I'm Dylan. Welcome to the home of the Robo Wranglers and me. Let's go check it out.
Oh hey, welcome to the field.
What's up? This is our boiler. This is where all the magic happens.
This is our peg. Bring it up.
Welcome to the treehouse. Money. All right, let's head up to the Mentor Lounge. Welcome to the Mentor Lounge. It's only the coolest place in the house. Let's head down to the bunker, check out some of the classic cars. What's up? This is the bunker. It's where we keep some of the classic cars. We got a nice 2012 Rebound Rumble edition right here. It's all right. I mean, 2 medals, I mean, that's it. But this guy right here, 2013 model, Einstein baby, classic. Right here, 2010, almost Einstein. I mean, it's pretty good, but I mean, it didn't make it, so like, it's whatever. Over here, 2015 model, best ever, can't top it.
And we're back with check-in. Our next team up here, we've got team number 148. It's the Robo Wranglers. They're from Greenville, Texas. Guys, that was an absolutely awesome video. That was hilarious. Thank you so much for showing us around your crib. And is the full version of it up on your YouTube channel right now?
It'll be up as soon as we're done with the show, and it goes through our whole school.
Oh wow! Okay, cool. All 100 and all 1114 square meters of it.
Yeah, I'm pretty sure that number's accurate.
How ironic. Anyway, so welcome to the show. Can you guys introduce yourselves to everybody watching at home?
Sure. I'm Adrian Emerson, lead teacher on the Robo Wranglers.
Hi, I'm Madison. I'm a student leader on the team.
Cool. Well, guys, welcome back to the show again. So let's go over our topics for the week here. Let's start off with driving around. So last week at the end of your video, we saw that you had a driving chassis. What's the latest update on that?
So this past weekend, we've been working, and we now have all 3 of our drive bases almost done, all on the mechanical side, and we're turning them over to the Sparkies tonight.
Cool. So you built 3 drive bases. Do you build 3 full robots?
Yes.
Yeah, we started that last year, and we found it really helpful. Well, I say last year, but 2015, we semi-started it because we had, obviously, Batman and Robin, practice Batman and Robin, and then we really needed to redesign the stackers on the Batman arm. Okay. And we had the drivers practicing, and so we couldn't really redesign something at the same time. So we had enough spare parts for the sheet metal to make just a frame out of Batman. And we actually called it Super Cart for a while because it was a frame with wheels on it and like no electronics or anything. But and it was just really, really helpful to have like a development robot and a practice robot. So then in 2016, we made the decision to do 3 full robots, and it was really, really beneficial to us. And so we're doing the same thing this year.
Yeah. It really helps. We can have one for driver practice and then one for our programmers for Auton.
Wow, that's awesome. That's a really like smart idea. I mean, I know a lot of teams don't build 2 robots, but more and more teams are starting to build 2 robots, and it almost it almost in my mind seems like, oh, who's going to start building 3 robots? But when you guys explain it like that, it makes like absolute sense how you would want to do that.
Yeah, we really like it. It's a lot of work, but it's really worth it.
Yeah. So is that kind of part of the reason why you guys have, or I should say, is this because of the sponsors you have, you're able to do this? Or was it sort of you had to go out and find extra resources to be able to make this happen?
It's definitely from our sponsors. We're so gracious for them. IFI is able to turn around sheet metal so fast. It's amazing.
Nice. That's always good to hear. Cool. So they're driving around. Good to hear. Since you're making 3 of them, are they all acting about the same? Have you found any problems with them so far, or is everything going well?
Only one is driving around right now because the other 2 don't have any electronics. So
that's okay. Cool. You found any?
We did a lot.
You can make for those?
Sorry.
Or? No, it's all right. Go ahead.
No, what were you saying, Francis?
Are you guys found any improvements you want to make from the first one to the next 2?
yes, already we have. Have some updated sheet metal tonight actually. So we're changing those up.
Biggest change was bottom load in battery.
Yeah.
So our bumpers, we had already planned on, setting the robot in or mounting them from the bottom. But we found that our battery was basically inaccessible, which would be okay in the pits. But when we were trying to turn around quick, like in elims or in practice matches, it was going to be virtually impossible to change the battery pretty quick. So,
So previously the battery, you'd have to take the bumpers off to get to the battery. Is that how it was, or?
No, it would just be from the top. So there would be a lot of things on top of it where it wouldn't be accessible.
I see. Okay, cool. Well, that's a good thing. It's a good thing to find out now than before you get to your first elimination match and all of a sudden you can't change the battery.
Yeah.
All right, cool. So let's talk a little bit more about your guys' hopper. It looks like you guys have been redesigning it. That's what we've heard. Can you tell us why you're doing that or what the reason for that is?
We, and this is not an exaggeration, have had a new hopper at every meeting this week.
Yeah.
Wow.
So I guess I should say hopper / intake to shooter feeding mechanism. So
Okay.
we're kind of grouping that into one, but we have just been trying to figure out the best way to get our balls into the shooter, and we just haven't really been super happy with anything that we've had so far. Luckily, we are making a lot of our prototypes out of Lexan, and we actually have a router that will cut it for us. So if we can just design it, we can cut it in 20 minutes or something, and we can try something new the next day. So we've been focusing a lot of energy on that this week, and just trying different things, and we have a lot of faith in the one that we're putting together today. So next week we'll have to let you know how it goes.
Awesome. So I gotta sort of poke at this a little bit. Is it the feeding the balls into the shooter that's the issue, or is it the organizing the balls within the hopper itself? Where are you finding difficulties, or maybe it's everywhere?
Yeah, right now it's mostly feeding.
Okay.
We don't really have a way that we can feed as fast as we want to shoot in a way that's reliable.
Yeah.
And that's really hard to test until you have the whole robot, because if you're trying to piece together this thing, we little cardboard sides that we taped on and doing all this stuff, and it's not realistic conditions. And so, a lot of our parts are not working the way we want them to, but it's just because our prototypes are kind of crappy. And so we're really just trying to, put realistic conditions in and figure out what is going to work and what isn't.
Okay, cool. That makes a lot of sense. I've heard a lot of teams have spent, as much time prototyping their intakes or their collector, their hopper mechanisms, their feeders as they have their shooters. It certainly seems true with you guys. So that's really great to hear you guys are making progress, and I wish you luck with this new one. Are they building it right now behind you all, or?
Yes.
Yep.
Okay, cool. So we won't keep you too long. I know you guys are interested in that. So speaking of your shooter, we haven't seen any footage of it in the last couple of weeks. Where are you guys? How do you guys stand with that? Are Are you guys getting more happy with it? I know the last thing we talked about it, you guys were building a type out of sheet metal for it. Where do you guys stand on the shooter front?
We feel really confident in our shooter mechanically right now.
Okay.
So we have spent a lot of time the past few days tweaking our software for the shooter, and I think I will be saying this for the rest of the season, that's what we're going to be doing at most meetings, right? And I think that's probably true of a lot of teams in first that are going to be shooting balls.
Yep.
So, but mechanically, we feel very confident in it. So now we got to see if we can get the software up to the confidence level that we have in the mechanical capabilities of the shooter right now.
Okay. Is it more, does your software testing, is it more along the lines of like target acquisition, or is it trying to get the balls to exit at the same velocity every single time?
All of the above.
Oh boy. Ooh, okay. Yes.
Our targeting system seems to be probably working better of those things right now, but I think there's probably still some work to do.
Okay, cool. So at what point are you going to decide that, so you said you're happy mechanically. So does that mean that you guys are in the process of building a shooter for each of your robots? Or are you still waiting to play with it from the controls perspective a little longer before you hit the button and start making them for real?
I think we're waiting a little bit.
Yeah.
Hopefully we'll get one done and then put it on the drive base and see how that integrates and how it works, and then maybe go to the next two.
Okay, cool. That makes a lot of sense. And I guess the other thing is when you're testing your different shooters and how they work with the hoppers, or I say when you're testing your different hoppers, do you have to test it with the actual shooter every single time? And how does that work when you guys are trying to also do code changes on the shooter itself?
Saturday Rev Hopper was on the shooter. Monday Rev Hopper was proof of concept. And we're trying to do we're going to do some more integration on that, but we've recently just gone into Tuesday Rev Hopper and kind of like skipped over integration for Monday Rev. So we'll see. If we're happy with today's, we'll probably skip integration on yesterday's. If we're not happy with today's, we might go back to yesterday's. And it was promising, just we think we have a better idea.
Nice. Okay, well, that's good. You got to make sure you act on a hunch, because you guys, you don't want to be waiting around just trying to see if things are going to work or not. So the last topic we want to touch with you guys is awards. So we heard that last week you guys the two of you were actually working a lot on the chairman's essay and also the Woody Flowers essay. Tell us where you guys are on that and how that's progressing.
Tonight was the final chairman's meeting for the essay and the questions, just making sure everything was right, and we're going to submit tomorrow. Just final touches on both of them, I think.
Yeah. Woody Flowers, we basically are trying to rewrite our conclusion because we actually, just like Spectrum earlier, had reached out just to have some people review it. So we had a couple of the engineers on our team review it, and Karthik actually went over it for us and gave us some really good suggestion, and kind of felt like our conclusion probably wasn't as strong as it could be. So we were reworking that, but everything else we're really happy with. And chairman's, one of the main things we were working on today was we felt that our essay was a little too busy. So we actually worked on taking out some topics that we think are going to play better in the presentation.
Yep.
Instead of on, really we're focusing on the past few days with that.
Nice. That makes a lot of sense. You don't want to overload the judges with everything in the paper. You want to try to present a holistic explanation of what you guys actually do. So the next question is any other last award things you guys are working on? I know you guys mentioned the Woody Flowers essay. I don't want to poke too much into that because I know it's a private topic a lot of times with teams, but is it thumbs up? Happy?
Yeah, I think so. We haven't told the mentor that we don't tell the mentor that we're nominating. I think, some teams do and some teams don't, so we don't. But I'm really happy with it. And I think that the students are too. And, we'll see what happens. There are a lot of deserving mentors out in the community, so you kind of never know.
Yes, that's certainly true. It's it's one of those awards that I've been lucky enough to have two mentors that mentored me both win it, and they both explained to me that it's great to win it, but at the same time you always think about all the other people that deserve it too. So it's an award that it's great to be nominated either way you put it. So always great to hear.
Absolutely.
Cool. All right, so we got a question coming in from the people in the chat. Again, if you have questions for the teams, you can ask them to us using the !Q followed by the question in the Twitch chat. So we got our first question coming up here right now. Hopefully, all right, here we go. So the Squirrel Lord, thank you for your question. So again, we wanted to sort of phrase this in a yes or no form. So how do you guys, the question is, will you guys be collecting gears from the floor? So we talked about the shooter and the collector and the hopper. We've seen the chainsaw a lot. What's you guys plan with gears?
Yes, we will be
Yes?
collecting from the floor.
Yep. We think that it's important for our strategy. We don't necessarily think it's important for all teams.
Yep.
But we think it's important for our strategy, and we actually spent a lot of time on Saturday with the drivetrain and the intake practicing scoring gears. So, yep.
Very good. And judging by the fact that it's not on your list, I assume you're fairly happy with how it's performing so far?
Yes, this is our second or third rev of the intake, and we're happy with it now, so that's good.
Cool. All right. Well, guys, thank you so much for joining us. It's great to hear how your team is iterating over and over again on all aspects of the robot. And I really, really can't wait to see that reveal video in a couple of weeks. Up next, yes. Up next on Check-In, we've got our last team for the night. It's Team 5803. They're Apex Robotics from SeaTac, Washington. We're going to take a very quick break and bring them on. But before we go, ladies, thank you once again for joining us. It's always a pleasure to speak with you, and we hope to see you guys next week.
See you
Bye-bye
then.
for now, though.
Bye.
All right, welcome back, everybody. Our final team for check-in this week, it's Team 5803, Apex Robotics. They're from SeaTac, Washington. Welcome to the show, everybody. Glad you're here. Let's introduce everybody. Let's go start with Evan, then go to Landon, then go to Maura.
Hey everybody, I'm Evan. I'm one of the lead mentors for Apex Robotics.
Hello, I'm Landon. I'm one of the student leads on the team.
Hello, I am Warren McDougall, and I am the head programmer.
Cool. Well, welcome to the show, guys. Now, you may also notice that these guys are also in a different layout than they normally are. You guys had a snow day today, too. Is it? That's kind of weird for Seattle, isn't it?
Yeah, it's pretty rare. I think we got more snow than we have in like 5 or 6 years here. There's like, I don't know, 7 or 8 inches at my house and probably about 4 inches at the school, which more than about an inch of snowfall is pretty rare. So we just don't have the infrastructure, the plows and things to clean it up. So schools get canceled, and that means that we can't meet, unfortunately.
Ooh, that kind of stinks. But I know that you guys do a lot of stuff remotely anyway, which is good. So you're not completely out of touch. And you know what? A snow day is always fun every once in a while too. So, all right. So let's dive into it right now. Let's talk about your robot design. We saw a lot of great pictures in there from your CAD. It looks like you guys have a full CAD ready. It looks like your robot, your practice robot at least, is pretty far along. Let's get some talk to us about that a little bit.
So this week we got our magic carpet done. We got the gear assembled, and then we also got our collector assembled without the motors and ready to be attached to the robot. And then also on my side for electrical, we also got our electronics panel finished.
Nice, very good. So it looks like a lot of great work is done. Do we want to sort of take a look more closely at the robot parts and sort of see what everything looks like and sort of give an explanation as to why everything's the way that it is?
Yeah, I think that'd be pretty cool.
Cool, Evan. I think you have the ability to show us some pictures of your CAD model.
I can do a screen share. Let me get this ready for a second. So we'll start with just the chassis and the sort of ball intake mechanisms. I'm ready to share.
All right, here it comes.
All right, should be coming up.
Oh, there we go. Excellent. Oh, and it's gone. Uh-oh.
All right.
It's back. All right, whatever
I figured
you
out what the problem was.
Go ahead, Evan.
Okay, so is my mouse showing up too?
Yep.
Excellent. So at the front of the robot, we've got an intake, and it comes out a little bit just to the front edge of the bumpers. We didn't want to do an over bumper intake, and I think Landon can get into a little bit of the details about why later, but it mainly had to do with robot size and not reducing the size anymore. And then in the middle, we've got what we affectionately call the magic carpet. Jennifer Hogue, who was on the show last week, she coined that name. She made sure to let us know that we needed to give her a shout out for that one. But it's basically just a powered floor that kind of slopes back towards the shooter, which is not shown yet. And then we have the gear mechanism on the back, which we call the gearer. And it's pretty simple. It's a lot like what I think Spectrum's shown, and it's just a top roller with a bottom plate and kind of sucks in the gear, and it's very compact in the back of the robot, which is one thing that we really like about that.
So is yours made of carbon fiber though?
No,
Okay,
ours is
so
made of
not quite as swag
polycarbonate and aluminum.
Not quite as swag as Spectrum.
Unfortunately. And then the other thing you can see in the front here attached to our intake is the climber, which is not fully fleshed out in the design yet, but it's basically just a 1.25-inch drum that will figure out exactly what rope and how we're capturing it later.
Okay.
Another thing to point out is on the chassis, if you look, we only have 3 wheels. So, as shown in an earlier episode, the inset, and that will come into play hopefully during when we're hitting the field hop ball. We can hit it with that inset wheel, which is not a wheel, to better get a hit and drop the balls into our hop ball, which is
okay. So that was the secret sauce you guys were hiding.
That was the secret sauce. The little cut off corner in the back of the robot is to help us trigger the hopper while the fuel tank of the robot is in position to actually get the balls from the hopper. So it's also just to leave space for us to extend something out there if just hitting it with bumpers doesn't work.
Okay. So let's take a look at some of the other parts, like maybe the shooter or the hopper parts.
Let me see if I can get this to switch to another picture here. I have to stop sharing for a second and share again.
Ladies and gentlemen, this is the lovely particular aspect of Skype.
And Microsoft.
And
Microsoft's new photo viewer doesn't like to flip through pictures, so I can't just hit the next button, unfortunately.
So what are we seeing in this picture?
So yeah, go ahead, Landon. Why don't you explain
So
this
in
one?
this picture, you see our shooter as well as what we like to call the funnel. So the magic carpet brings all of the balls into the funnel, and then the funnel will make it to where only one ball is going to the shooter at a time. And then you can't really see it right now, but the two blue wheels that we are using, we're using a smaller one at first for the booster stage, because during prototyping, what we were realizing is that our two big wheels were leaving a gap to where we were just losing the momentum and so forth of the fuel when it was leaving the shooter. So that smaller ball is there so that we can just easily get more torque, etc., to bring it to that ball without having that empty gap in between, because we're able to push them a bit closer.
Okay, very cool. So when you guys are talking about the funnel, whenever I hear funnels and robots and stuff, I assume that's a huge point of potential jamming for the balls. How have you guys mitigated that?
All right, I got it. I got just the picture here.
Oh boy.
Oh boy. Okay.
When it's not the black nothing, it is.
Stop sharing. Share screens. There we go.
All right, here we go. All right, there we go.
So this is what the back of our ball feed mechanism looks like. So we've got, and I just want to give some credit right off the bat for our design inspiration. Is heavily based on the sort of ball intake and powered floor is heavily based on 254 Cheesy Poof's 2006 robot. And our funneling mechanism is very heavily based on Symbotic 1114's 2009 robot. And we spent a lot of time sort of looking at old robots and how they solve these challenges and put it together. And this is, I don't have a video of our prototype handy, but this is the prototype that was hidden a few weeks ago at the end of our video.
Cool.
And so essentially have two powered wheels here counter-rotating that take a 2-ball wide stream and funnel it to a ball and a half wide and then to 1 ball wide. And it uses the powered wheels to kick them over to make sure that they don't jam. And that's the part that's cribbed from Symbotics. And it works pretty well. At least the prototype did. We haven't had a chance to run the competition or the actual design yet, but it's kind of worked almost as well as the original versions, which has been awesome.
Very cool. That's awesome. That's great to hear. I like the fact that you're using other previous designs as inspiration for your new one. But a very serious question, actually. That sprocket right there in the middle. How do you get that sprocket to stay between the chains like that?
It's called it's magic, really.
Oh, okay.
No, it's called a floating tensioner. You can see these on a few other robots, and it doesn't require anything special. You got the chain on the top moving one direction, the chain on the bottom moving the other direction, and somehow it just stays in place.
Well, I still don't get it, but either way, whatever, it works. No, That's a bit of a joke between Evan and I, but cool. So do you have any other pictures you want to show us before we move on to talking about the software and the controls part of the robot?
Yeah, I've got one more that I think is pretty neat. Let's pull this guy up here. Stop sharing, share screens. So this is the roller system that we use to power the balls kind of through the funnel. And the really cool thing about this is it's like 90% commercial off-the-shelf parts.
Oh, wow.
Most of this is West Coast product stuff, but we've got Vex Pro HTD pulleys that run between the rollers, West Coast products roller system end caps and roller tube, and then West Coast products 775 Pro GT2 3mm pinion going to a hex bore, half-inch hex bore 60-tooth pinion, and then belts are just either from West Coast products or for odd sizes from STPSI. So the only part that's actually custom or precision machined on this whole thing is this plate here that was made by our sponsor Aerotech.
Nice.
And so it's pretty neat to be able to put together a system like this with just parts that you can buy that don't require much precision machining. And I would hazard to say that you could probably recreate this entire system with all COTS parts with like a versaplanetary and some chain instead of the pinion and belt.
Yeah,
And,
but I mean, it's good to if you have the capabilities to utilize them and sort of make the solution more custom fit to your design.
Well, and you'll actually notice that we have two holes right here. We can swap a versaplanetary into this if we need to.
Oh, yeah.
We were hedging our bets that in case the reduction wasn't big enough, and we needed more torque on this system, that we could just do that without having to make modifications.
Cool. That's a very smart idea. Awesome. Well, guys, thank you for showing us all of your mechanical parts there. That's wicked cool. I look forward to seeing the final robot assembled. I know that you're almost there. But let's talk a little bit about the controls portion of things. So where are you guys standing? Where do you guys stand with that? How's all the programming going? Have you started to wire your main chassis? We saw some speed controllers going in on the video. So let's talk about that.
So I'll quickly put my chip in on the electronics. So for the electronics, we got our electronics panel done. So we ended up having 13 motors, but we just realized that we're using the Spartan board, and it only has 10 PMW ports.
So can you explain what the Spartan board is?
So the Spartan board is a board created by 971 and is distributed through West Coast Products, I believe. But it it simplifies the Robo Rio into very easily used ports, and then also adds a gyro in. Evan, do you have any other things to put in on that?
Yeah, I mean, one of the nicest things about it is that it adds latching connectors. It uses latching Molex connectors instead of the regular PWM headers, so that keeps everything from coming out of the Robo Rio. Holds the cables in, and it's got the gyro on it, which we were hoping to use this year, but it's going to be on its side, so we have to use another gyro. And it also provides regulated 12-volt power to sensors that get plugged into it, especially encoders. So if you're using Talon SRXs, those will do the same thing if you plug your encoder directly into the Talons. We use mostly Victor SPs, so if we're using encoders, we like to be able to have the regulated power from the Spartan board.
Cool. All right. So let's talk about the software then. Maura, I know that you're one of the lead programmers, so tell us how the status of all this is.
Well, the software is actually going pretty good. We have all our manual code pretty much completed without all of the PID. And before we knew about what the electronics were doing, we created a new class, a multi-speed controller class that lets us use 6 speed controllers at once. But then we found out Saturday, we can't use that.
Oh, why not?
So, well, It's not
Landon.
yeah.
Blame Landon.
I was going to mention this quickly, but so
Blame
when we
Landon. Really
realized
quickly,
that
talk
we
about
had
it, guys.
BMW ports, we ended up having to use a Y connector. And we're using two Y connectors on two of our drivetrain motors,
Oh,
which
I see.
now makes it to where that special code that they made no longer works.
I see. So you found a hardware solution to a software problem.
Yeah.
Well, we found a hardware solution to a hardware problem that negated a software problem that they'd created a solution for already.
Okay. So,
It's good practice. Good practice.
Cool.
Builds character.
So beyond that, Maura, what else is going on with the software?
We have been updating our vision tracking, and we found out that the camera that we bought, it was an Axis camera, caused grip to crash.
Ooh.
And we used a USB webcam, tried that out, and it actually worked way better. So we're going to be using something around the lines of a webcam than a regular camera.
Very nice. So have you managed to start implementing some of the vision stuff on like an actual drive base, getting it to line up and find distance, or are you still trying to grab images through grip? Excuse me.
Still trying to get grip set up with our kangaroo, and we haven't really connected it to a robot to like practice test firing or anything. We've just connected it just to use the Robo Rio.
I see. Okay, cool. And just so the people at home understand, what is a kangaroo beside an animal from Australia?
A miniature PC. Think of
Okay,
it
good.
as just a regular desktop computer you carry around, but it's the size of a slim brick.
Oh, okay, cool. So it's not you're not
It's
actually plugging anything into a real kangaroo,
No.
like an animal. Okay, good. All right. It's good
I
to
don't
hear.
think those are less than $400.
Oh, that's true. Well, you never know. We have to ask our friends in Australia. Cool. So last thing we want to touch on is setbacks. What kind of setbacks have you guys seen? Obviously, there's a snow day today, which is way out there for Seattle.
And
what else has
yesterday.
happened? And yesterday
And
as well.
Yeah.
Ooh,
It
that's
froze.
nice. Ooh. So what does that mean for your team now?
So one setback that definitely put us a little bit behind was finals week, which was week 2 or 3. And the thing that hit us hard is just we had a lot of students studying and going home after school. So we didn't have the whole entire team at each meeting.
Oh,
So
yeah.
we were making some progress, but not huge leaps and bounds. And then also some things in the CAD, as everyone knows, is not just like it's going to go together in real life. So
Yeah.
just in building some of our mechanisms, we've hit a few minor hiccups. So that and the snow day, but
Yeah.
a few extra days and then maybe lengthening a meeting or two, and we should be right back on track.
Very cool. Good
And
to hear.
also, can I add that sickness, a plague, kind of took over our school
Yes.
and
I
caused
heard about
everyone.
that last week. There was a mass illness from a lot of
Yeah.
folks, a lot of sick folks before
Yeah.
finals. Ugh,
Yeah,
that's-
so we're about a week behind our ideal schedule, I think. We're not actually that really any farther behind than we were last year. So we know there's a clear path to having 2 robots up and running by bag day, but we're just we're trying to get something together for the software team so they can have a real robot to run stuff on and actually bring it online. You were asking about testing the vision code on a drive base. Well, we stole all the electronics off of our Party Parrot drive base to put the practice robot together. We
I
only have
see.
2 sets of electronics, so they have to wait until we finish this robot before they can do anything.
Oops.
Yeah.
Well, that's all right though. You're building a practice robot anyway, so they'll have the whole season to play with it if they want to. Cool. All right. Well, we got a question in from the viewers at home. They want to ask. So again, for the future, if you want to ask questions, just do it in our Twitch chat. This question is from 9 Jerry. He asked, "Could you show us some high-speed video of your funnel next week?" I got to agree with Jerry. That sounds like wicked cool. I hope you guys have it running. I'd love to see some video of it working.
Me
What do you guys
too.
think?
Yeah. I think if it's running, we'll have some video of it. I'd love to, have some side by side of our prototype and the real one.
Yeah.
Hopefully working better than the prototype. But we got to finish a robot first.
Cool. Well, that's it for tonight, guys. I want to thank you for joining us here on Check-In once again, like you've done the last 4 weeks. For everybody watching live, if you like the show, you want to see more, make sure to follow us on Twitch and follow us on subscribe to us on YouTube. And if you want to learn when all the interesting things that RSN is doing are happening, follow us on Twitter or on Facebook. You can search for Robo Sports Network or Robo Sports Net on Twitter, and we're right there. But for everybody here on RSN, I want to thank 5803 for joining us once again. And we hope to see you guys next week, and we hope to see everybody back at home next week as well. So until then, have a great week and good build season, everybody.